Hi everyone. Today we're going to learn a little bit about layers in the soil. Should you need to get a hold of me, my email address is on the screen. I'm rcrawford@jcpsmail.org. Let's jump right in. So when we look at soil layers, we don't call them layers, we call them horizons. Together, if we have several layers of soil, one on top of another, we call that a soil profile. And so we have five basic layers in most soils. The top layer is something called the organic layer. Next, we have the topsoil layer, followed by the subsoil layer. Then we have a parent rock layer. And then underneath that, we have bedrock, which is that layer of solid rock. Let's look a little bit more at the organic layer. The organic layer is the top layer of soil. The organic layer is going to have two basic types of things that make it up. The first is something that's called surface litter. Surface litter is the fresh and recognizable bits of organic matter that have not yet fully decomposed. So in other words, if the things that you can see and still tell what they are, they're not fully decomposed. You might see fallen leaves, you might see a dead mouse, you might see animal droppings or scat. Things like that that haven't been decomposed yet, we call that surface litter. After after the organic matter is fully decomposed, it's been there for a while, so it's old and it's no longer recognizable, we call it humus. So humus is the old unrecognizable bits of organic matter. They're completely decomposed and you can't tell what they are anymore. Humus turns out to be really important for soil. It gives a lot of soils that we might think of as being fertile, they're dark color, and it is a very, very helpful substance to have for plants. So humus starts out, of course, on this top layer, but it eventually works its way down off into the topsoil. And so, as time moves, earthworms, insects are pretty good at mixing the soil. And so the humus makes its way down off from that organic layer down off into the topsoil. The humus, its primary job is to keep the soil from becoming what we call compacted. You may remember that we said an ideal soil has water and it has air in it. Well, for water and air to exist inside of a soil, there has to be open spaces for it. And we call these open spaces between soil particles, we call those pores. So humus actually keeps the soil from being compacted and it keeps these pores open. And so humus is very important. Humus makes soil very, very fertile. So the next layer down is, of course, topsoil. Topsoil is going to be the fertile layer of soil. This is where most of the nutrients and minerals needed by plants, we're going to find it in the topsoil. Nutrients like nitrogen, phosphorus, potassium, those are things that plants all need. In addition, this is also, we've said, this is where our humus is going to move to. And most of our decomposers are going to live here, sort of on this boundary between the organic layer and the topsoil. When we see plant roots, plant roots don't really go down as deep as we like to imagine that they do. Uh, Most plant roots are going to stay here in the topsoil. Really, without this topsoil, plants just really can't survive. And so topsoil turns out to be really important for plant growth and for fertility, which makes topsoil important to us. So let's take a moment to make sure we understand how soil forms. So I do want to point out that it takes soil thousands and thousands of years to form. Soil is not something that is created very quickly. You may remember that soil begins to form from weathered rock. So we have perhaps water that is dripping or falling down with precipitation onto bedrock, gets into cracks or it dissolves it, and so it begins to disintegrate it. So we start getting some bits of weathered rock that are part of the soil. The next thing that's going to happen, oh, I should point out the rock that we start with, we call that our parent rock material. So this is the material that the soil is formed from, and so we call it the parent. So after when the soil begins to break, after the water begins to break down the rock and weather it, we find that we're going to have a few types of plants and simple organisms that are going to be able to move in. And mostly plants and organisms that can take this really poor soil. They're going to move in and they are going to grow. And of course, as they grow, they will eventually also die and drop leaves. And that's going to be our first introduction of some organic matter. Of course, we know that that's going to improve the soil quite a bit. Over time, we know that we're going to have uh, these bits of rock at the surface. They're going to become more and more heavily weathered. They're going to get broken down into smaller and smaller grains. And then before you know it, we start to have these distinct layers that begin to form. Um, and then finally, as more and more plants are able to move in, more and more organic matter begins to be introduced to the soil, and more decomposers to begin to live there, which makes our soil rich and fertile. But it's important to remember that all soil starts with rock that is weathered down, and then we have a few early plants that are able to take up residence in this poor soil, and they begin introducing organic material. So we keep having this weathering, and as it weathers, the layers form until finally we have even more plants, and then we have a lot more organic matter being introduced into the soil. All right, guys, when we talk about soil formation, one thing that has a huge impact on soil formation and how fast it happens is rainfall. I would say that's the single most important factor that impacts how fast a soil will form in a particular place. Now, temperature also matters, but rainfall, how much rain is going to be available to weather that rock. So if we look at places like this rainforest, places with warm, wet climates, we're going to find that the soils here are going to form relatively quickly. That's because weathering and decomposition are going to happen much, much faster where we have warm, wet climates. On the other hand, if we were to look at something like this desert, or if we were to look at the Arctic tundra, places where we might have cold and or dry climates, we're going to find that the soil forms very, very slowly there. So rainforests, because they are warm and have a lot of water, we're going to find that soil forms very quickly there, whereas tundra and deserts, places that are dry or cold, the soil is going to form very, very slowly there. All right, guys, that's going to do it for today. I hope you have a great day.